Yesterday, we started a brand new section on inverse trig functions, which were basically the opposite of the regular trig functions, right? So instead of going from an angle to an endpoint, we're going from an endpoint to an angle. Now, before we go on for today, and I actually am going to set this down here so I can see you. I just want to go through one little thing that I talked about last time that can be kind of confusing, okay? Now, when we talk about inverse functions, we take a trig function and then we put like a little -1 on top, okay? Now, I don't want you to confuse this with a power, okay? We're not taking sine, cosine, and tangent to a -1 power. This is just saying inverse sine, inverse cosine, inverse tangent. I know it's very confusing that there's a -1 raised to a power and it's not a power, but just keep that in mind when we're going on. Okay, so we did talk about sine, and I think we did a couple examples that we didn't get to last time, but I think it's a good chance to kind of review everything. Okay, so when we did inverse sine questions, I told you that there were a few steps, right? The first step is to rephrase the question, right? We want to figure out what we're actually looking for when we do a sine question. Second, we're going to find everything on the unit circle that answers our question, right? So we're looking for all of the angles that work. Usually there's more than one, okay? Third, we talked about sine, and we said that sine didn't actually pass the horizontal line test, which meant that it didn't actually have an inverse. Now, to kind of combat that, we did this thing called restricting the domain, which we'll talk about later for cosine as well. But we said that the answer for sine or inverse sine can only be in quadrants 1 or 4. Can't be in any other quadrants. So we have to kind of look at our angles and make sure that it's in the correct quadrant. Number 4, sometimes we get an angle that's in the correct quadrant, but it's not actually between the two numbers, -π/2 and π/2. For example, it might be in the correct quadrant, but it's not like represented the same way. So to kind of combat that, usually we subtract off 2π to make sure that it's in the right quadrant, or it's between the two numbers. So why don't we do an example together, and then for those of us who did this on Friday, then we can kind of go over those answers as well. Let's go to example number 4 and just go through how we do this again. All right. In this example, we want to figure out the inverse sine of -√2/2, right? So we want to know what that number is. Step 1 says to rephrase the question. And what I mean by this is if we're trying to find what inverse sine of this number is, another way to say this is, what angle can I take the regular sine of and get -√2/2, right? So that's what I'm trying to answer. Okay. Step number 2, we're going to take a look at our unit circle, the one that I gave you, or our paper plate unit circle. And is the sine the y value or the x value on the unit circle? The y value, right? So we're going to look and see what angles have a y value of -√2/2. Okay, what angles do that? Good, 5π/4? 7π/4, perfect, right? Those are the two angles that give me a y value that's actually negative, and it's -√2/2. All right, going on to step number 3, we want to figure out, okay, we know the answer is either in quadrants 1 or quadrants 4. Now, the two angles that Sarah gave me on the unit circle are here and here, right? 5π/4 is on the left, 7π/4 is on the right. Which one is in quadrant 4? 7π/4, right? So that one is the correct one. That's in quadrant 4. So we're going to keep 7π/4. And then step 4 is a little bit tricky, okay? Step 4, we're trying to figure out, okay, is 7π/4 really between -π/2 and +π/2? And what I mean by that is 7π/4 between -0.5 or 0.5 pi? Well, it's not, right? 7/4 is definitely bigger than 0.5. So what do I have to do to kind of make this an answer that looks right? Subtract off 2π, right? So I'm going to take 7π/4. I'm going to subtract off 2 pi. And what this does is it gives me a coterminal angle, or an angle that represents the same picture, but a different number. To do that, I'm going to find a common denominator. So 4. 2 pi is 8 pi over 4, right? So when I subtract this off, I get negative pi over 4. All right. Any questions on example number 4? All right, so let's see what we haven't done so far. We didn't do example 5, example 7, and example 8. Now, I think some of you have done this before. What do I want to do? I think what I want to do is maybe next class we can kind of loop back to this so we can write this on our iPad without having us sit around. Why don't we come back to these examples and then we'll keep going with class for now. All right. So skipping ahead. Now we're going to talk about cosine, right? So we talked about inverse sine. Let's talk about inverse cosine, and we're going to have to think about the same thing that we did with sine in terms of restricting the domain here. Okay. Now, I guess we were studying for a quiz last week and we figured out how to draw cosine. What point would I plot at x equals 0? So what would be the y value at x1? Good. What about pi over 2? 0. What about pi? 3 pi over 2, 0, and then 1. Perfect. Right, so cosine's the function that kind of looks like a U, right? It goes down, and then it goes back up. And if you look at the left-hand side, it's literally just going to be a copy of the right-hand side, right? So you don't have to be too precise here. But if I were to figure out what it looked like on the other side, it would look like this. Okay. So to find out if a function has an inverse, we have to pass the horizontal line test. Does this function pass the horizontal line test? No, right? It doesn't. If I take a horizontal line and move it up and down on my function, okay, this horizontal line is going to touch the function a bunch of times as I move it up and down, right? It actually touches the function an infinite amount of times. So this definitely does not pass the horizontal line test. Okay, so it does not pass HLT. Okay, and to make it kind of forced to have an inverse, what we're going to do is the same thing we did with sine. We're going to do this thing called restricting the domain. Now, we're going to do it a little bit differently than what we did with sine because cosine is a little bit different, right? I'm going to take my function between 0 and pi. If I highlight off that section, that specific section does pass the horizontal line test. If I ignore everything else, right? So if I just take that part of the function, ignore everything else, that does pass the HLT. If I take this section, that specific section does pass the HLT. And even like the negative values pass the HLT. If I just take those pi increments of my function, okay? Now what I'm gonna do is, since mathematicians like numbers close to 0, and they also like positive numbers, we're actually gonna focus on the pink shaded one, okay? So what we're gonna do is we're just gonna focus between 0 and pi, okay? And what we're gonna do is we're just gonna ignore everything else in this function except for the values between 0 and pi, okay? So now this is what mathematicians consider the part of the function that we care about. And this very short function, let's see if it passes the horizontal line test. If I kind of lasso this around, if I take my horizontal line, move it up and down, the function only touches the horizontal line once. So we do pass the horizontal line test, okay? So what we're doing is we're kind of forcing this function to have an inverse. The reason for this, or the consequence of this, is the only answers for inverse sine can only be between the two angles that are prevalent in the function, right? So the only answers for cosine or inverse cosine can be between 0 and pi, and that's it, no other values. Okay. Now let's take a look at the unit circle here. If I kind of just draw a bad version of the unit circle, I know that 0's here, pi over 2 is up there, pi is to the left, and then we got 3 pi over 2 here. What quadrants are between 0 and pi? 1 and 2, right? Because quadrant 1's there, quadrant 2 is there. So in this case with cosine, the only answers we can have is between quadrants 1 and quadrants 2, nothing else, okay? And what this does is that it actually makes inverse cosine questions a little bit easier to deal with, and we'll talk about why that's true. But let's flip over to the next page and kind of put this all together. All right, so when we do inverse cosine questions, we still have our 4 steps. Step 1 is rephrasing the question, just like we did with sine. Step 2, finding all the angles on the unit circle that answer our question. This time we're probably going to focus on the x values because we're dealing with cosine. Step number 3, we're going to make sure that our angle is between 0 and pi. So we need our angle to be between quadrants 1 and quadrants 2. Okay. Step 4, we actually don't need to find a coterminal angle, and I think it will make a little bit more sense when we do an example. So there actually is no step 4 here. Okay. Let's do an example, and hopefully this will make a little bit more sense. Let's say I wanted to find the inverse cosine of -1/2. Well, if I want to do step 1, I'm asking myself the cosine of what angle gives me -1/2, right? That's what I'm asking myself here. Okay. I know that cosine is an x value. Can someone give me any angle that gives me an x value of -1/2? Good, 2 pi over 3. And looking at the rest of the unit circle, is there anything else? Yeah, 4 pi over 3 also does that, right? So I found 2 angles on the unit circle where the x value is -1/2. All right. Now, 2 pi over 3, if you take a look at your unit circle, it's actually like up here. And then 4 pi over 3 was down here, okay? Which one is in quadrants 1 or 2? 2 pi over 3, right? So 2 pi over 3 is the angle that we actually care about because that one's in quadrant 2. Okay, so we're going to ignore the other one because that one's in quadrant 3. All right, now let's just talk about this. I got 2 pi over 3, that's in quadrant 2. Is 2 over 3 pi between 0 and 1 pi? Yeah, right, because 2 over 3 is between 0 and 1, so 2 pi over 3 have to be between those two numbers. We don't need a step 4 for any cosine question because we're always going to be between those two numbers. We're always between 0 and pi. So there's no need for a step 4 here. 2 pi over 3 is our final answer. All right. Let's see what I want to do here. I actually want to do example number 6 with you. So why don't we skip over example 5 for now? I'm going to do example 6, and then we're going to compare, or we're actually going to go through this together, sorry. All right, let's do example number 6 real quick. I want to find the inverse cosine of 0, okay? Step 1 is rewriting my question in terms of something I can think about. So I'm looking for an angle that I can take the cosine of and get 0, right? Okay. So take a look at your your unit circles. What angles give me the cosine equaling to 0? Pi over 2. Is there another one? 3 pi over 2, right? So I found the 2 angles on the top and the bottom, 90 and 270 degrees. Okay, let's take a look here. Which one of these 2 angles is in quadrants 1 or 2? Sorry. Well, none of them are in either quadrants, right? These represent boundaries of different quadrants, right? So pi over 2 is kind of like not in quadrant 1 or quadrant 2. It's kind of just up in between quadrants. 3 pi over 2 is between quadrants 3 and 4, but I think I talked about this on Friday. Boundaries we kind of just accept the boundary to be in either 2 quadrants. So if we're looking at pi over 2, I'm just going to consider that to be in quadrants 1 and quadrants 2. The same thing for 3 pi over 2. So which one of these two do you think I'm going to take as my answer? Pi over 2, right? Because, well, it's not in quadrant 1 or quadrant 2, but it's technically in quadrant 2, it's technically in quadrant 1. So I'm going to keep that as my answer. So pi over 2 is my answer. I said for inverse cosine, we don't need to think about changing the answer because our answer is always going to be between 0 and pi. So this is my final answer. All right. Any question on example 6? All right. Now these can get a little bit tricky to think about at first. So I'm going to have you try example 5, 10. I did not mean to make that example 10, but 5, 10, and if you flip to the back, there's 2 others. I'm going to give you a few moments to work on this, and then we'll come back to this. But I promise, if you go into calculus or any further math classes that involve inverse trig, I feel like this is the thing that like just gets everyone kind of forgets this. So I want to make sure that this is like drilled in to our brains when we do this later on. All right, so example 5, let's see, who wrote up this one? Was that Paige? No? Oh, Ainsley, okay. Ainsley, do you want to go through example number 5? Mm-hmm. Mm-hmm. Perfect. So we got pi over 4 for example number 5. Any questions so far? All right, now I'm not going to get everyone to explain these because I feel like the explanations are kind of the same. Why don't we do one more explanation, then we'll go through the rest. Example number 10, who wrote that one up? Halson, do you want to take us through this one?
So, as the cosine of that equals -1 and
Mhm.
pi is the only angle that is. So that is with quadrant 2 and quadrant 3.
Good, right? So this one was one of those boundary questions, but we still got an answer out of it. So nice job on example 10. Now, I think the explanations are kind of the same after this, right? So let's kind of skip over the explanations for example 11. Example 11, we got 5 pi over 6, and example 12, I think I saw everyone get pi over 3. Any questions on these examples? All righty, then I think we're good for inverse cosine. Let's talk about tangent. All right, so let's do 5 more minutes and then we can go to picture day, which is always my favorite day of the year. All right, so we talked about sine, we talked about cosine. Tangent's going to be a little bit different, okay? And that's because it's harder to go from the unit circle to values to tangent values. So we'll talk about what to do here. But first we have to talk about if tangent actually does have an inverse, right? Okay, so tangent. Where are my asymptotes for tangent? Where are the asymptotes? The places where a tangent doesn't have a value. Pi over 2, good, 3 pi over 2. Actually, any odd power of, or odd multiple of pi over 2, right? So any, if you basically start at pi over 2 and go 2 blocks to the left and to the right, we have these asymptotes, which are just things that our function gets really, really, really close to, but doesn't touch it, right? Now, if I were to draw my tangent values, it kind of looks like the disco man in between each of these two. So kind of looks like that cubic function, except my y values kind of stay in between the asymptotes and it doesn't go any further outward. So my tangent function looks like this. Okay. All right. Do you think this function passes the vertical line test or the horizontal line test? Sorry. No, this doesn't pass the horizontal line test. If I take a horizontal line and move it up and down, the tangent function is going to touch it every single time we have one of those disco men, right? It's going to touch it every single time. Okay. Now, how do you think we're going to restrict the domain this time? What do you think we're going to focus on this time? Well, if I take a look at one of the disco men, one of those disco men, if I ignore everything else, that kind of passes the horizontal line test, right? So that specific part that I highlighted has an inverse. The same for this one, right? And the same for this one, right? So each of the different sections does pass the horizontal line test. It's just when I combine them all together that we don't have an inverse, okay? Which of the disco men do you think I'm going to keep? Well, 0 is always important, right? So I think I'm just going to keep the middle one, okay? This is what mathematicians kind of do in general. Mathematicians consider the restricted graph of tangent to be just the middle one, okay? So everything between negative pi over 2 and pi over 2. And we just ignore everything else. This is kind of like our graph of tangent that does have an inverse, okay? Because of this, the only x values that are plotted are between negative pi over 2 and positive pi over 2. And because of this, our answers for inverse tan can only be between these two values, negative pi over 2 and positive pi over 2. Okay, what quadrants are negative pi over 2 and pi over 2 in or between? 1 and 4, good. The same thing as sine, right? So we said that the sine graph could only be between 1 and 4 because everything between 0 and pi over 2 are in quadrant 1. Everything between 0 and negative pi over 2 is in quadrant 4. So our answers for tangent can only be between those two quadrants. Now, the big question is, how do we actually find those tangent values, right? So how do we go from a tangent value to its angle? It's not as simple as just looking at the unit circle, right? Tangent values aren't on the unit circle. You kind of have to figure them out. And the way we're going to go about this is actually using our chart, right? So I told you that for tangent, we have to memorize the chart of values for the first quadrant, okay? Now, let's just go through these real quick. Who remembers the tangent of 0? This is easy. This is 0. Yep. 0 is the easiest one. Pi over 6 is a little bit more tricky. Does anyone remember it? This one's actually the square root of 3 over 3. The way I memorize this is 3 plus 3 is 6. So I know that the tangent has 2 3s in it, or the pi over 6 has 2 3s in it. Does anyone remember pi over 4? That would be the sine and cosine. Since they have the same value, does anyone remember what pi over 4 would be? 1, good. That one's another easy one to remember. Pi over 3, I think this one's easy to remember because it has a 3 in it, and it's just 1 3 square root of 3. And who remembers what happens when pi over 2, we're taking the tangent of that one? Yeah, DNE, undefined, something like that. Okay, so when we're doing inverse tangent, we're going to reference this chart because it's going to make it a little bit easier and faster to go between values of tangent and this angle values. All right, now I'm actually going to end class a little bit early today because it is picture day. Okay, so